Let's kick off with your career in technology.
Yeah, thanks, Paul. Good to chat with you. Career in technology. Starting from the beginning, I'm born and bred in Queensland, a state of origin night to night, so it's a parochial Queenslander. But I grew up in a family that was quite a working class family. Parents. My dad was a tradesman, and I used to earn pocket money with him to help make. He was a boiler maker, so a bit of a side hustle. I'd come home after school and help cut up steel and make things, and it was probably slave labour, but he actually managed to pay me for that, and the money I saved up. Initially I bought a remote control aircraft, and this probably stitches into the story a bit later, and it didn't quite work, and my dad was getting grumpy and sent it back, and so I took it back, and rather than a refund, they gave me a credit, and I might try that computer.
Right.
And it was a VIC-20. So this is back, I was looking, VIC-20s came out in 1981, it was probably 1983, but I love tinkering with things. I think it was an engineering thing. I was always pretty good at maths naturally, a bit of a rat bag at school. I think I was a bit bored and things like that,
Sure.
but I found maths super easy. And then, just started playing around with this computer on the weekend. And it came with BASIC, so it's self-taught to BASIC, and then started mucking around trying to write games, and they wouldn't really, I think I was probably 14 years old.
Right.
At the time, the games weren't really quick enough, so I read up somewhere you need to write them in assembler. Didn't have the money to buy an assembler program, so I wrote my own assembler in BASIC, and back then it had 5K of memory.
That's
so
right.
you had to sort of switch stuff onto the cassette tape as the drive, and then load it back and get your numbers right. That enabled me to play around, mucking around with sort of sprite games and things like that. They were pretty quick, written in assembly, so self-taught assembler program. And then part of school, I ended up, there was a a computing module on Apple IIe's in Maths 2 back at high school back then, and sort of just breezed through that and went in the state comp around computing, and I think our team got a distinction or something like that, and then I just sort of parked it at that stage. I did qualify to get into university, but again, parents are going, why go to university? I got a job with the government.
Right.
You're set for life. The job I got was measuring rivers, so maintaining electronics equipment for the water resources, collecting lots of data.
The gauges and so on.
That's right, and then you would also take discharge measurements, a lot of field trips in Cape York, based up in Mareeba in far north Queensland.
Right.
Really exciting couple of years,
Lots
going
of rainfall
in helicopters and four-wheel drives, and then they'd send programs up from Brisbane. Didn't really work. I'd fix them and send them back, and they even looked at putting me on a sort of computer operators course in the public service then, but one of my mates who was an engineer said, you should be going to university. So I pulled the pin after 2 years and saved up enough money to be independent at university, and my parents drove up to try to talk me out of it. But that was then, I got enrolled in computer science. So that was 1988. So I was, probably had a couple of years of work. I was probably 18, 19 years old. Just took to it like a duck to water.
Excellent.
And scored pretty well. Pretty much was topping the year after the first couple of years, and got offered a cadetship with Department of Defence with DSTO, the Defence Research Organisation. So next minute I'm flying down to Adelaide 4 times a year, and I got assigned to Hornet Radar Systems, which was actually the F-18 support, research support for the radar signal processor. And what they assigned me to was looking at sort of trying to understand the dynamics of the machine and how it translated its assembly code. And we hadn't learned assembly code at uni yet, but I was self-taught assembly code, and I had written an assembler, and that's sort of what I was doing a few years later on a $12 million computer in the front of an F-18. So it was a little bit of a turnaround from a VIC-20 with a cassette tape drive. So I spent, I had 2 years of the cadetship there while I was finishing off my, I did an honours degree. But my bosses there sort of said, in DSTO, without a with a science degree, even an honours degree, in a research organisation, you really need a PhD.
Sure.
So we sort of set it up, and I ended up taking a university scholarship at UQ for my PhD, and I focused on safety critical systems engineering because when we were working on the F-18, all this assembler code, and it was quite a little complex operator. It was kind of the instructions were very vague about what would work and what wouldn't work, and I was really curious if this is doing terrain following and things like that. It's you kind of want to know that the software is going to do what you want it to do.
Yes.
So I was really quite interested in that sort of precise, how we can build more precision into how we do software engineering. And so I did my PhD focused on safety critical systems engineering. So a lot of mathematics, a lot of mathematical modelling. But I kind of looked at configuration management, like as we change components, how do we know that these components are still going to perform appropriately and whatnot. I did that PhD for I think about 3 or maybe 3.5, 4 years full time. Had a little bit left. Took me another 2 years part time to just, I think, tidy up edits and things like that, and finally get the degree. But when I was when my scholarship ran out, I still got a research role at the research centre, the Software Verification Research Centre, and I was working more on the applied research back in defence. So working on projects like NOLCA, the ANZAC ship combat system, and things, and also other safety critical areas like the railway systems and so on. I sort of I did that for probably 4 or 5 years, and then the research centre was a really good opportunity. But what really piqued my interest was the applied research, actually working on, and I think it came back to that tinkering things, building things. I think a career in academia was not for me in terms of that postdoc thing. I really enjoy building systems, working in new business domains, and really understanding how that works and how to develop and design systems in that space. So after that point, I decided to leave the research centre and set up my own consultancy business. And that was in 1997. So that was the formation of KJ Ross and Associates, which is now called KJR, that I'm the owner of. And at the time I thought, it'd be really cool to do a bit more applied stuff, but maybe not so much in defence and railway safety, but branch out a bit more into banking and other areas. It'd be cool if, maybe I get 3 or 4 of my postdoc mates to, we find some interesting projects. And then over the years that just sort of grew. Next minute we had 20 people and 30. Holy crap, I'm running a business and stuff like that. And now KJR's it's coming up to 28 years old, and we've got over 100 consultants, mainly Brisbane, Sydney and Melbourne. Brisbane, Melbourne and Canberra, sorry. Not so much Sydney.
And focused on safety critical systems?
We're mainly focused on software assurance and software quality testing and evaluation. So I sort of switched out of the systems assurance space, and a bunch of my colleagues are still very much leaders in that space on things like the autonomous trains and work in air services with the air traffic control. And it was interesting, that research centre, even though it doesn't exist anymore, the capability that it created and how that's still really deeply embedded here in the Australian industry. So a lot of that alumni are really, really key roles, particularly in that safety critical area in defence and mining and transportation. But I sort of took a little side thing and focused a bit more on the test and evaluation side. KJR sort of initially focused on software testing, software automation, a lot around sort of performance testing where we actually write scripts, and like with the bank scaling up, what happens when 10,000 users hit like a e-banking gateway or something like that. So a lot of our work has been in that space. And then some of the work is stepping out of the technical into the governance space, so looking at regulation and other areas like that. And now, what's probably been a bit dominant in the last 10 years, a bit of my career sort of got back into that that data side of things and focusing a lot more on AI and sort of data-driven approaches. We're sort of finding all the systems now are really starting to use data and big data to make decisions, and that's becoming more pervasive with our customers.
Right. So let's turn to your involvement with ACS. How did that start?
Yeah, so I signed up to the ACS while I was at university.
Right.
And then, quite involved while I was doing PhD. With the Software Verification Research Centre, we had a pretty good association with the uni, with ACS.
Yeah.
And part of that, while I was there, they asked me to help set up and operate a special interest group around, I think it was around software verification initially.
Right.
And then when I left and formed my company, I ended up creating a special interest group in software testing here in Brisbane.
Right.
So part of that was how do we get the community, both academic and industry community together in those sort of special interest groups. I've always been a big believer of I think we're to have a really strong professional association, something I've been connected to. But it's always a bit of a challenge sharing that with some of our, even my employees around the value of those professional associations and that lifelong learning component. It's really critical. But I'm a big believer of, building a strong professional network. So it's not just the technical things we learn, but how do we really fit as part of the community? And then, that association was also part of, how do we volunteer and contribute through the special interest groups and things like that to build communities, and I've been on several committees. I think it's really important for something like the ACS to exist there. But something we think a lot about as well now on some committees is what is it that the ACS can drive that participation. Because it's not a take, it's a give and take thing that really is required from people.
And you're currently sitting on the AI Ethics Committee, which is very much a topical subject at the moment. Where do you see that going?
We just had our in-person meeting last week it was the National Technical Committee for AI Ethics.
Right.
And it's probably for the chair to announce, but we're looking at potentially changing the name of that. That's not denied or confirmed at the moment. But maybe focusing a bit more on AI safety. Because ethics is sort of like read as just one part of what we're looking at. That committee's been interesting, and there's a lot going on in that space, not just within the ACS, but with the National AI Centre, and I've been part of the Queensland AI Hub, and then I'm part of Standards Australia for the ISO standards in AI. So there's a lot going on in the space, and I think the interesting thing that the ACS committee could play that I think is really in ACS's sweet spot is what are really the skills element of the technology industry that are really relevant to this future of AI. There's obviously standards and ethics and regulation, things like that. But I think if the ACS thinks about what's really the skills and capability we need, what's that ethical code of conduct and ethics framework that we as technology people operate under. In many ways, I think AI is going to impact our technology sector before many other sectors. Certainly what we're seeing at the moment with the large foundational models is they're really driving coding. How the role of a coder is operating. And certainly that'll impact the software quality side and business analysis side and other parts. So in many ways, eating our own dog food is probably going to eat our industry quite dramatically over the next 5 years. And there's an element of what is that skill set for the general public and industry that really is that technological understanding of AI that's really crucial, because we'll find that more people through AI will perhaps make technology more accessible and more maintainable. So there's actually a skill set for the general public as well. So a lot of work to be done, I think, on that front, and really an interesting role for the ACS to play in that space as well. So I think I look at AI as a really exciting time. I describe myself as a cautious optimist. I see a lot of opportunities, but having worked a lot in verification, validation, test evaluation, systems assurance, safety, I think we need to approach that with some caution and put the right guardrails in place and really think about incredible capability, but what are the guardrails and the guidelines that we need around it?
Well, that leads very nicely into the next question that I ask of all of the interviewees on here is, where do you see the future of the IT sector? And you're very much front and centre of that at the moment.
Well, if I look back from the mid-'80s, I think, in the early days of IT, it was trailblazing, with some of the first people to get, email and internet and things like that. But pretty much back then, technology was in the back office, right? Rarely seen in the front office, where now technology is at the forefront and the forefront of the way industry thinks about itself, the way the community thinks about itself. So I think technology is so much more pervasive than when we started, when I started my career. And I think it's going to be more and more that way. And I think the challenge is how we increase that technology literacy, in the broader industry and community. So I think, the technology that we're seeing coming out with AI, we've never seen anything like it before. The capability to sort of do that stochastic processing, being able to understand language, whether we get to AGI and, that point of super intelligence, who knows? But we will see a remarkable technology that people will harness. I think the big challenge we've got at the moment is people understanding and rethinking the way they process things at the moment. And they need that technology understanding for the light bulb to turn on. But I think we're going to see a lot of transformation in the next 5 years. Certain sectors are going to be a bit cautious and slow, and I think that's the challenge for our large institutions and government. And then there'll be certain pockets of very rapid acceleration, and there'll be sort of alarm bells that will ring off in some places, and sort of restraints being attempted to be placed in others. But I'm pretty excited. I joke with my grads, my career's almost done. You guys have got to rethink your career now. But I think the technology will be at the centre of things for a long time to come. But really understanding where we cooperate now with some of these emerging technologies to do it, and what will happen to the older skills and things like that. That's something I'm still concerned about how certain groups or certain professions or sub-professions might be left out or start disappearing. But my approach to that throughout my career is always having that lifelong learning attitude as well. So again, the ACS is key to that in terms of maintaining that professional sort of learning component and the special interest groups and whatnot. But that embedded, I think, in everybody is something to staying relevant as technology changes the world we're in.
I would imagine too it varies between sectors and industries. Like you mentioned aviation, railways, defence. You've got highly regulated industries, very very much front and centre, safety first, and then at the other end you've got the broader tech startup community where it's let's just break things and see what happens. Well, definitely where you see AI advancing at the moment is in that break things and see what happens, because pretty much driven by those highly profitable sectors that are sales and marketing, finance, things like that. Where really, by making advances and the risk exposure maybe is not as high. Things like cyber and things like that are still, privacy is still very key things, but they definitely take that approach of a fail fast
capability. Where something like railways and defence, very cautious and regulatory, but even there it's confusing. Like one of the really powerful group, or not powerful, but one of the groups that have done really well is the I think it's called the Australian Safety Critical Systems Club or something. It's a part of the ACS.
Yes, that's right. Yes.
So they hold a conference each year.
They do. Yeah.
Very sort of focused group into that defence sector with all my old colleagues, and I've given a couple of keynotes over the years on AI to that group.
Yep.
Again, that industry, highly regulated, as you said, around might be an aviation standard that is very specific about how they assess risk and how they mitigate and address risk in technology. Very highly skilled.
Yeah.
But then in those situations, it's kind of like an example is in railway. Yep. Very regulated, very how to build those controls, long history of safety assurance. But how might we involve, like AI with computer vision to improve safety on a level crossing or something like that?
Yeah.
It doesn't really fit into the standard, but that's what they want to look at now. How do we adapt these things that actually improve safety? But we haven't quite got our head around this new technology in terms of how deterministic it is and our insights into its behaviour and trust. So there's a lot of work for those guys to do to satisfy the regulator. In the meantime, it's sort of like the regulator's under pressure because this thing could actually up safety a bit, like the discussion around driverless cars. But there's a lot of caution. You kind of think, is that counterproductive to the safety argument? So, it's an interesting time in that space.
Good position to be in to influence policy and regulatory.
And I think around the world, there's different groups trying to look at AI, like the AI safety institutes that trying to understand how are these things learning, how do we better understand the sort of the corner cases that are being established or understand their explainability to have better insight to how they're performing. They're all things that we've got to do as a profession to better understand how we're harnessing that technology from the original imperative coding rules approach that we're all been comfortable with since we created computers.
So last question, probably one of the biggest ones, is what's your advice to anybody looking to enter the industry today?
That's a really good question. It's going to be interesting the way that AI will impact the roles. But I think trying to go into uni and second guess all the subjects you should be doing that's going to be suitable for 5 years' time or 10 years' time, no one's got a clue, right? So my recommendation, somebody new coming in, is thinking about what are those sort of skill sets to give you the base theoretical components. That's what you would focus on at university. Something that's going to give you a really good foundational structure to be very adaptable in the world moving forward. Because I think as it has throughout my career, it has keep changing and new things coming up. But I look at what I learned at university was quite good around some of the foundational things that have carried forward. And some of those subjects might be the math subjects and the sort of statistics subjects and things like that are really relevant. But then I think the other recommendation is, really encouraging people to have that lifelong learning journey to their career. Pretty much, you're trying to get your degree is to get your first entry into your first job. After 2 years, employers don't look at what uni you went to and what your grade scores were so much.
Exactly.
And so, really it's that choice then of how I get placed for those initial graduate roles and things like that. My advice to young people about that is to get out of the uni and start networking.
Right.
Use the ACS, use those networking groups. Try and set up some internships and placements while they're studying. Get out into industry and start building that professional network, because that will be as valuable for them moving forward. And then obviously with AI, they've just got to keep their skill set diverse, really focus on the critical thinking, really think about the value of communication, teamwork and things like that are really critical to moving forward. So and then, depending on the role you get, you'll see, I say to my own kids, it's about the what do they call it? The sliding door effect. The
That's
door
right,
slides open, you go through it, and
Yep.
you just keep going through those open doors as they open up and explore where that takes you to.
Mm.
Yeah.
Yeah. Well, on that tone, let's call that a day. And thank you very much, Kelvin, for participating in the interviews.
Yeah, thanks, Paul.
Thank you.